Welcome to Talking Postgres. It's a monthly podcast for developers who love Postgres, and I'm your host, Claire Giordano. In this podcast, we explore the human side of Postgres and databases and open source, which means why do people who work with Postgres do what they do, and sometimes how did they get there? Thank you to the team at Microsoft for sponsoring this conversation. Today's guest is Andres Freund. Andres is a Postgres major contributor and a committer and a member of the 7-person Postgres core team, which is like a steering committee for the Postgres open source project. And he's been working on the Postgres database for more than 15 years. He's employed by Microsoft, where he works full-time on Postgres open source, and he's lead of Microsoft's open source contributors team and has been since 2019. His fingerprints can be seen all over the Postgres source base, but in a good way, including things like logical decoding and scalability, and most recently, asynchronous I/O. Welcome, Andres.
Hi, thanks for having me.
I'm so glad you're here. And it's time to talk about today's topic, which is what went wrong and what went right with AIO. Now, for regular listeners, they probably know that this is not your first time on this podcast. For people who are interested in your origin story, how you got started as an engineer, as well as in Postgres, you can just go ahead and listen to episode 8, and we'll be sure to drop that into the show notes. That was really about, well, actually, you weren't the only guest on that episode either. It was you and Heikki Liinakengas, and you both shared your stories about how you got started. I can speak. But before we dive in, I'm curious, like, what do you work on mostly these days? Is it all AIO, or are there other things on your plate as well?
It is primarily AIO related, but it's not so much the AIO subsystem itself, but working on the infrastructure to be able to use AIO in more parts of PostgreSQL, which is not really directly touching AIO pieces, but like redesigning other subsystems so that they actually can use AIO. There's also some other performance-related work and similar things, and trying to help out some others too.
So some context for people who are listening. Postgres 18 is about to GA. It's about to release in general availability. And release candidate 1 is available for anybody to download and check out the release notes for right now, correct?
Yes, that is correct. And please test and report back if you find any problems.
Yes, because this is the chance, if there are any showstoppers, to catch them and get them fixed before the GA. But AIO, asynchronous I/O, is part of the Postgres 18 release, but that doesn't mean it's over yet. And the goal of today's discussion is really to kind of explore your journey leading that project and like what went wrong, what went right, what happened. So I guess we should start with why did we do it and when did it start and what's the beginning of the AIO project for Postgres?
The beginning is probably even further back than me starting to work on it. Personally, I've been interested in adding AIO support to Postgres basically shortly after I started using Postgres, somewhere early in the 2010s. But I only started working on it like around 2019. It might have been late 2018, I don't know. But the reason for why we did it was that Postgres, until very recently, basically relied on the operating system to do efficient reads from storage. For some things that works rather well. For example, if you have a sequential scan or something similar, the operating system, or at least most operating systems, can do reasonably efficient read ahead. And that allows Postgres to not be blocked by storage. But if you have anything more complicated, like a bitmap index scan or a bitmap heap scan or a vacuum that skips blocks or something similar, then the operating system can't do this read ahead for us because the operating system doesn't know as much. So it can't look into the future and do read ahead because it just doesn't know the future, even though Postgres could know the future, because we know what we're going to do in the future. So the goal of this is to basically give the operating system and the storage the information to do a more efficient reading. And one motivating factor for why I started around that time was that Linux had a new feature called IOUing, which allowed to do asynchronous I/O in more cases. Before that, Linux had asynchronous I/O support and had that for a long time, but it only worked with direct I/O. What that means is that it only worked if we did not use the kernel page cache. But it turns out that that's much harder to use, and there's also a lot of use cases where that's not really the right setup to use. So with the introduction of IOUing, it was suddenly possible to do native AIO in more cases, and that's kind of what made me start looking into it. At the same time, there were two important changes, I think, afoot. One was that we had much faster storage than we used to do due to NVMe storage. That's fast local SSDs that can have very large bandwidth. And it turns out that the CPU overhead of doing I/O suddenly matters a lot more when having that fast storage. And at the same time, more and more workloads were migrating into cloud systems where you could have storage that has reasonably high number of IOPS or a reasonably high bandwidth, but the latency towards the storage is fairly high at the same time. And that means that to saturate the storage or to fully utilize the storage that we pay for, one actually needs to issue I/O more in parallel than we could do until recently. And that was the second motivation, basically, for investing time in working on I/O.
So let me see if I follow that properly. For both of those changes, both with NVMe as well as with workloads in the clouds with these large IOPS, are you saying that those were opportunities to take advantage of? That's not what I heard. I heard you saying that, wow, we really needed to fix this problem because it was becoming a bigger problem. Did I get it right?
I mean, that's kind of the two sides of the same coin. Either we would need to benefit to fully utilize the hardware, or we're not performing as well because we're not utilizing it. But otherwise, okay. I think you're right.
I'm just looking at it the more negative way. We had to do it. We had no choice. Well, maybe it's true that you had to do it because you were so motivated and had been thinking about it for, it sounds like 8 years.
Something like that, yeah.
Okay. So that's why. Had you ever led an architectural change as big as this?
I don't think so. I've worked on reasonably big changes to Postgres, but they were all more narrow. They didn't need changes to as many parts of Postgres, and they were more focused. And even though I think some of them might have actually been more lines of code or something like that, if you they were never quite as hard to integrate because they touched fewer places. So this was definitely the hardest project I've ever worked on.
So how did you even begin? How did you get started? I mean,
it's long enough ago that
prototype.
that I'm not 100% sure about all the details anymore. But I think I just started out doing some very minimal testing, in the sense of I try to do the minimal hacking on Postgres to use I/O in one very narrow place, and then try to see whether I could see any performance benefits from that. And initially I didn't. And then I just started trying to use it in other places to see whether there's bigger gains there. And eventually I learned more about what the problems were and where we can really gain performance. And I started to try to generalize how the I/O subsystem would look like in a somewhat understandable way. And over the next couple of years, I on and off worked on developing an I/O subsystem that was generic and tried to introduce uses of it in more and more places. And as part of that, there were lots of sub-projects that were like somewhat independent and could be committed independently. And there were improvements to Postgres that could be committed even though AO was not merged. For example, I think Postgres 16 or 17, I don't fully remember, 16, I was able to commit a change to make relation extension that's like making the table bigger, faster. And that actually was interesting to do because it allowed a fairly substantial part of the architectural changes that were necessary to be merged into without the rest of the AO changes. And generally, that's something we tried to do, was to find like bits and pieces that we can merge earlier, because like trying to merge the whole thing at once was just going to be infeasible. That was clear pretty early on.
Now, I know that in Postgres 17, there was a feature or a collection of features under the umbrella name of streaming IO.
Yes.
Was that considered part of the AIO project as well?
That was definitely one fairly crucial part. And as part of the prototype for AO, I had written something that was called at the time, I think, streaming read, but like it was, streaming read. And then Thomas Munro tried to make what I had prototyped into something more general and independently mergeable. And that is what got merged into Postgres 17. And that had substantial benefits on its own, because what it added was the ability to merge multiple IOs for individual blocks. In Postgres, those blocks are typically 8 kilobytes large, into one larger read of up to, by default, I think 128 kilobytes, if they were neighboring blocks. And that alone can reduce the CPU overhead of doing IO very substantially, because fewer system calls are required.
Okay. So
And
the
it
title
also,
of
the other
today's...
the other part why that was
Go.
interesting is that it
Okay.
allowed us to introduce users of AO without actually having AO merged, because the whole idea behind this interface that was added to 17 was that it allowed code to have the same interface in 17 as they would have in once AO was merged with that, and then automatically get AO and also already get some other benefits before that. And I think that was a pretty good path to take. I think that's one of the things that went well.
Okay. So what we want to cover today are things that went wrong and things that went right, which is a little bit different from what you did when you gave a talk a couple of months ago in Montreal at pgconf.dev. And there you focused primarily, and the title of that talk was just what went wrong with AIO. So, but here we want to talk about both, those big challenges and things that went wrong, as well as what went right. You just talked about something that went right? That you seeded some of these changes into Postgres 16 and Postgres 17. So it wasn't a big bang code contribution, if you will, in Postgres 18. But I guess my question to you is, do you want to weave these two things that were good and things that were a problem together throughout today's conversation? Or should we actually start with the what went wrong part? How do you want to do it?
I think either for me works okay. I think maybe it's easy for the audience if you do separate the two, but I'm sure that even if you do that, there will be some back and forth, just because that's how our brains work.
Because you can't help it.
Yes.
Okay. So you talked about in that talk at Montreal, which I listened to, I was there for part of it, but I also listened to it again this morning. You talked about a handful of mistakes, but you also talked about why it took so long. And are you happy or not happy with how long it took? Did it take the right amount of time as a project?
I think it definitely took too long. And I think there's like several reasons why I think it's too long. One is just that it's extremely hard to maintain motivation and over that long time. And I think some of the slowdown was just related to needing to do something else just because I couldn't see the word AO anymore. And if the whole project had taken shorter amount of time, then that would have been less of a factor, I think. But I also think that it took too long just because, like, in the sense for like, it would have been good for Postgres for it to have happened sooner. And there were plenty of other projects that were kind of blocked by not having AO, and also several people in the community in our team at Microsoft were helping with AO, and they would probably have been happy if that happened more quickly, because at the pace it was happening, they had needed to switch back between helping out with AO or doing AO related projects and doing other projects. And that's the more context switches one has, the more, for a lot of us at least, then the slower things go.
I guess I wonder if you're being too hard on yourself saying that it took too long. I mean, by definition, don't big projects go down dead ends? Isn't that like a normal part of the design process? That there will be dead ends, or there will be things that you wish you hadn't done the way you did in the prototype?
Yes, that's definitely part of it. And I think good part of like a project of this complexity, I think it's impossible to do without exploring dead ends, because otherwise one wouldn't have been ambitious enough to find the actual right design, and would have just gotten stuck in some local minimum of okay-ish design. But I think there probably were cases where I could have done better. Like, I invested a lot of time in trying to make the prototype kind of work in some edge cases, even though like there were just known fundamental architectural mistakes in the prototype, and like that cost like at least a year. And if I had like focused more on like giving up the prototype at some point and just starting with a real thing, if I had done that earlier, I think it would have been better. But I think there's also a second aspect of issues that were not related to me personally, or where I did something wrong. I think there are like a lot of the time that it took for AO was that we had like some aspects of Postgres where we just hadn't invested the time necessary to make it like to allow for faster paced development. Like, one aspect is that before I started working on AO, Postgres did not have CI that could be run by everybody. And for something that has so many portability effects like AO has, that is just not feasible. Like, if we can't automatically test Postgres on different operating systems and so on, then it's not really feasible to develop something like AO. And so one of the large timed sinks that I was on the web path to getting AO anywhere was to merge CI infrastructure into Postgres. And that took a lot of time. And if that hadn't been the case, then the AO project would have gone faster. And I think it's an area of Postgres that we just as a project had underinvested in. And I think even though there was some initial skepticisms about adding CI, I think that has generally borne out to be a very crucial enabler for lots of different projects.
Now, that's something that Bilal worked on, right? Nazir Bilal Yavuz? Probably
Yes.
other people as well.
Yeah, I think
Okay.
it was Bilal and me were doing a lot of the work initially, and then since then, plenty of other people have chimed in. But I think in the last couple of years, Bilal has done most of the work.
I had no idea that that was an enabler, if you will, for the AIO project. That's pretty cool. I thought it was a general improvement to the overall way the Postgres, contributors and engineers tested the project, but I didn't realize there was an AIO connection.
I started doing
I'll say thank you.
purely because of AO. That was directly the motivation. So.
Okay, then. That should go on Bilal's I don't know, his next promotion justification or something like that.
I'm pretty sure that I did that.
Okay, good. So do you want to walk us through since a lot of the people that listen to this show are engineers and developers, they probably are hungry to hear specific examples of things that decisions you made or dead ends you went down that you wish you hadn't. Do you want to give us some of those examples? Do
I
you
can
remember?
try. Some of them will be like a bit far down into the weeds. I don't know how easy they're to explain on a podcast, but I think one of the dependencies that probably should not have been a dependency was that I got very frustrated with running tests in Postgres before working, like while working on AO, but also while working on other features. And that indirectly led me down to adding support for a new build system to Postgres. And I think that was a very good investment into Postgres, but I think it was not a very good investment in the sense of doing it before AO was complete. And I think I knew that at the time. I just needed to do something other than AO. So maybe it was the right thing to do, but it definitely did not help the timeline.
Okay.
Another
And when
example
you
of like more
talk about
technical. Go ahead.
just how big of a distraction was that? Are we talking about 2 or 3 months on your part or a year?
It's hard to say because it was not like drop one thing and do only the other thing. But like the work
Right.
definitely went on over like 9 months to varying degrees or something.
Okay.
So it was a substantial
Okay.
time investment. Um,
Okay.
on the more technical front, I think one very hard thing about adding support for AO into something like Postgres, which just was not written with anything like asynchronicity in mind, is that one invariably needs something like callbacks or something to react to the AOs, to the completion of AOs. And I definitely went many different dead ends in how to make that correct and not super failure prone. And initially, one of the biggest mistakes was that I allowed those callbacks to start more IO within after the completion, and that turned out to have very complicated nesting issues because it then meant that if an IO completed while deep in some subsystem, then that more IO could be triggered, and that could then recursively re-enter the same subsystem, and it made everything very fragile and hard to understand. And I think I intuitively knew that that wasn't quite the right direction to go in, but like it was hard to go back and redo everything to get rid of that decision. And yeah, that was probably like the wrongest decision about all of this on a technical level. And what Postgres now has is a much more restricted level set of callbacks. Like one is not allowed to start new IO inside those callbacks. One is not allowed to allocate memory inside those callbacks, and like it's very restrictive. And that's good for some things, but it's also makes it a lot more restricted. And that probably will make some other features harder. But it's the only way I could see to make the feature actually understandable enough to believe in its correctness to some degree.
Obviously, if someone really wants to go deep on understanding some of the things you did that in hindsight, with 2020 hindsight, you wish you hadn't done, they can go watch your talk, which is available on YouTube, from Montreal, the What Went Wrong with AIO. And I can't remember if that was a half-hour long talk. I think it was. I think it was about a half hour.
I think it
Might
was
have been
45
longer.
minutes or something. It was the full length talk, but I'm not
Okay.
entirely sure.
So you dive deep in that talk. But are there a few other examples that we can kind of consider? I mean, what I want to get to after you share the examples is like, what's your takeaway? Like, are there learnings that other developers can steal from you, or that if you embark on a similar architectural project in the future, things you will know to do better next time? But before we get to the learnings, I just feel like we need to go through a few more examples if we can.
Yeah. Another example of like failures that were more like project failures rather than my personal failings is that they're just are, and particularly were, significant parts of Postgres that just had no tests. And it turns out that if you then redesign parts of Postgres, it's very easy to break those other subsystems that had no tests. And like, for example, we found out very late in the development of or merging of AO that it broke some the stats that are emitted whenever checksums, whenever there are checksum failures. But we just had no tests, so I just did not think about that until the last minute somehow. And I think as a project lesson, I think it's that we have to continue to invest more into testing infrastructure and different types of testing. And I think that's also, in a way, a personal lesson. Like I did, obviously, I invested time in working on CI and stuff like that, but I should probably have done more testing infrastructure earlier on to find some of the gnarlier, hard to find bugs. And yeah, that was not perfect. I think the development process was that I first wrote that prototype, and then only in like about a year ago turned that prototype into some, like, rewrote the prototype from scratch to get something mergeable. And I think we added too many features to the prototype. We basically had already learned nearly all the lessons that you could have learned, but I tried to make it better and better. Like, one big part of what you eventually want to use AO for is to do wall writes. And I invested like at least a year and a half into trying to make asynchronous wall writes work very well in all situations. Even though like getting the performance exactly right of that was not all that an important a decision. Like wasn't that important for the design of AO. It was important to prototype that we could do asynchronous wall writes, but it was not important to get the performance to be on par in all situations with current Postgres, because like it was always to be a prototype, not the real thing. So I invested inordinate amounts of time in that. And I think knowing when to stop with a prototype is probably something that I learned a lot about as part of this project.
Well, what is the answer to that? Knowing when to stop with a prototype. Like that's
I think
it's hard to give a rule of thumb around.
Yes. And I think generally the problems where things go wrong are not going to be hard and fast 0-1 kind of things where like there's a right or is it wrong. It's always a question of like a graduation where like at some point you go, definitely invested too much time in it. At some point you invested too little time, but like where exactly the right spot is a large bandwidth between those. And I think that's where most of the things that went wrong were like of that nature. And I don't think I know the answer right now. I know that the spot I picked in some cases was definitely wrong. I don't know where the right spot would have been.
Okay. So more examples.
One,
I'm putting you on the spot.
the way that the AO subsystem works is that one can get an IO handle, and then with that IO handle, one can associate like a read or a write and some callbacks that are to be called when the IO completes. Initially, there was no hard limit in each backend how many of those handles could be used, and it was actually somewhat expensive to get one of those handles. And because it was so somewhat expensive, all the parts that used those handles cached them for reuse. And it turns out that if you cache a lot of handles in a lot of places, that the total number of those handles can get very large. But because of Postgres's multi-process designs, the state for all of those handles has to be in shared memory, which then means that we have to pre-allocate them at the start of the server. So this caused a problem that we could run out of handles, and that then meant caused a lot of problems, because if we are in the place that wants to do, for example, wall write, which may not fail without taking down the server, and we ran out of handles, there was not really a good way forward. And that was like a multi-layered descent into wronger and wronger design. And it turns out that the root cause basically was that it was expensive to get new handles, and because of that, we had to do the caching. And without all of that, once it was cheap to get handles, the whole set of problems related to this went away. And I think I could have recognized that earlier, but I think that issue I feel not as bad about it as some others, because like that was just a new design space that we needed to explore, and in hindsight everything's easier.
Well,
Yeah,
in
I think
hindsight, it's all obvious, right?
not obvious, but more obvious maybe.
Okay. I like the phrase you just used. You said a multi-layer descent into wronger and wronger design. I'll replace wronger with bad, but I like that quote. Okay. Is there any takeaway from that, or did you just have to go through that exploration to get to that
I
to
think
that
we needed to
result,
go
right?
through
Making
that.
it get handles.
I think we needed to go through that exploration, but I think I should have, or we should have stopped earlier and did the necessary redesign to make to get rid of those the problems. And that was one of the things that make it really hard to work with a prototype, because like would lead to these nested subsystems that had very complicated problems that were interacting with each other. And I tried to put more band-aids on more band-aids, and that just made it even harder. And I think it like is related to the decision to stop earlier in the prototype and just rewrite in a cleaner way from scratch. And I think that's actually one of the positive lessons, is that for complicated projects, it really often will be worth it to write a throwaway prototype where basically no code will survive from the prototype to the real thing, just because by the time it is the right design will be clear, there will be so much garbage left in the prototype that it's not really worth trying to keep the code and going from there to something mergeable.
That's something that you said in your talk in Montreal, that in hindsight, you wish you hadn't spent the time you spent trying to get to production level quality in the prototype. Like if you knew upfront that this is going to be a throwaway prototype, you might have saved a little bit of time there. Is that the right takeaway?
Yeah, and the hard part of that is trying to know which of the problems in the prototype are architectural problems that need to, where it's not yet clear how the right solution looks like, and which are architectural problems that we now can fix because we now know about them, and so it's easy to avoid them while writing the real thing. Obviously, that's not a easily generally answerable question.
Okay. So before we flip to what went right with AIO, is there anything else that went wrong that gives you one of those takeaways, those learnings, those I'm not going to make that mistake again?
I don't know whether, like, I think one other big thing that it didn't go right, but I don't know how wrong it went, and I don't know whether I really know how to do it better, is trying to tackle a complicated architectural problem while collaborating with others. Because it is very hard while exploring something that is in an architectural void to share the problem space with somebody else and to try to delegate parts of the problem to them, because it requires a fair amount of experience and a fair amount of like tolerance for uncertainty, I would guess is the best way of describing it, to work in that void. And I think that's something that didn't go right in all cases. I think I tried to delegate some projects that were too underspecified and perhaps were too early. And on the other side of the coin, I think there were projects where I made myself the bottleneck for far too long and did not delegate, or did not delegate is the wrong word, did not hand off subsets of the problem to others. But it's very hard ahead of time to know which which side of the line some subset of some problem is going to be. And I hope I am getting better at it, but like I've been hoping to get better at particularly this task for a long time. So I don't know whether I am now better at it or whether I know the right solution. But yeah, I found
Well, I
that
think
to
that
be a very
anybody
hard problem.
listening,
Can
anyone
you say again?
listening who's a technical lead like you are is probably identifying with what you're saying. Because like you said before, like it's not like there's a right or wrong answer or a 0 or 1 answer, right? It's figuring out what can be delegated, and it's also who you're involving. Like some people are very good at tolerating uncertainty, and other people need things to be more clearly specified. And so kind of knowing that, right? Knowing those people and figuring out what to carve up. I mean, that's one of the big challenges of leading a
Yeah.
project like this. I don't
And quite
know.
often the problems,
I
it's not known whether they are a hard problem or an actually easy problem without first having spent the time to solve the problem. And that means that delegating the problem is like kind of a roll with the dice to see, like, and it might go well or might not, but without you having ahead of time the information to decide whether it's a good match.
Okay. So before we flip to what went right and to look at the things that you want to celebrate or you want to repeat or you hope others repeat, is there anything else that went wrong that leads to a lesson that you want to share with other engineers?
I think there's a lot more, but I don't know how much of those are worth investing time on this podcast. But maybe one interesting challenge around this was that it turns out that hardware is very diverse and has very many odd behaviors. I spent a fair bit of time trying to understand how different SSDs work across different workloads. And it turns out there's very little information out there to understand that. And some SSDs like much bigger writes, but very little I/O concurrency. But other SSDs, even from the same manufacturer in some cases, want a lot of concurrent writes, but not have them be very large because otherwise the latency increases dramatically. And that makes it very hard to have generally applicable auto-tuning systems. And I think we spent a fair bit of time trying to make subsets of the AO product like not have a lot of configuration knobs for every user, because like users are not going to know how to tune those. But I think we had a hard time finding good ways to do that, and that was definitely a challenge. And I think we went with very simple algorithms for now, but it's definitely not where it could be. And there's lots of challenges still remaining with like dealing with different hardware, and particularly because like no individual developer will ever have access to all kinds of different hardware.
Okay, so you're suggesting there's more work to do in the future, especially
There's a lot more
around
work, yes.
tuning. So before we dive into what went right with the project, maybe let's tell people like where is this project now and how much work, how much change is going to happen in the future in Postgres 19, in Postgres 20. Like, let's just state of the world, AIO and Postgres 18.
In Postgres 18, there are quite a few users of AIO. For example, sequential scans, bitmap heap scans, vacuum are all use AIO. And in several of those, it can lead to substantial speedups. The reason for the speedups actually differ somewhat between the different users of AO, but it is pretty decent speedups. However, there are very important heavy IO dependent paths in Postgres that do not use AO yet. And what the most crucial one is probably that index scans, like not bitmap index scans, but plain index scans, do not yet use AO. And that means that if you have a workload that does a lot of ordered index scans, for example, you're not going to want to, you're not going to benefit from AO, even though it's a workload that can, in theory, very, very heavily benefit from AO. There's a prototype for that's being worked on, or a project to add a read ahead for index scans. And in some cases, the speedups are like 8x, 9x compared to not using read ahead. And that also means that retract a tiny bit. One of the motivations for adding AO to Postgres was to be able to use direct AO. What that means that we do not rely on the kernel caching, buffering AO for us, and not the kernel with direct AO. The kernel also does not do any read ahead, and that can be a lot faster than relying on the kernel page cache. And it can avoid a lot of double buffering, where the same data is cached in Postgres' buffer pool and in the kernel page cache. But without supporting AO in a few more places, that's just not viable to use in any non-toy workload. Today, when turning on direct AO in Postgres 18, it is going to be faster for sequential scans in a lot of cases. However, if you ever have an index scan, it will be a lot slower than before, if that index scan can be utilized read ahead by the operating system. So I think one big part that is remaining is to just use AO in more places. Often that will not actually require a lot of work on the AO subsystem itself, but it will just require work in the subsystem that wants to use AO. For example, for the index scan, like a big part of the work is to the index interface, how to represent the ability to do more read ahead, or to present read aheads in there, and how to handle the pinning of buffers across for a longer time and similar things. And I think there will be a lot of other areas like that.
Let's pause for a second. So for users that are listening to this, the story is not yet written. Like Postgres 19 is likely going to have, so the Postgres 19 is the release that will come out in the September-ish timeframe of 2026, a year from now. It's likely to have even more users of AIO, potentially such as index scans, that will then reap the performance benefits for some workloads. That's what you're saying, right?
Yes, and I suspect that will go on considerably longer than Postgres 19. Although I think
so also more things in Postgres 20, etc.
Yes.
Okay, and you were about to say the second part
is that that AO in 18 is only used for reads. There's no writes that are utilizing AO. And
what? Okay.
Can you say that again?
But that's just because it hasn't been done yet, right? It's
Correct.
going to be used for writes in the future.
Yes, but in 18, we are not yet. And the reason for that is that there are lots of architectural issues outside of the AO subsystem that need to be tackled. That's actually what I'm currently working on, is to make the buffer manager ready to do AO writes. And it turns out that there's just a bunch of largely AO independent projects that need to be done to make that feasible. And then there is are currently patches to do some of the preliminary work to make it easier to later do AO writes, and some of them have like substantial performance benefits on its own. Melanie posted a patch to do write combining for writes in checkpointer, for example, and that can speed up checkpointers rather substantially. And I think it also does some of the work that we then later need to do to turn those into asynchronous IO writes. And that's a big, I think, set of improvements that we can do. And then, as mentioned earlier, one thing that I really want to do with AO eventually is AO writes for wall writes. And that will be a pretty large project that requires like infrastructure changes that are not really related to AO, but that will hopefully have their own performance benefits. Yeah, I think that's roughly the current state.
And if somebody is listening to this and they are a contributor to Postgres and they're not already involved in helping drive all of this future work for AIO in Postgres 19 or Postgres 20, like how do they get involved? It's just via the mailing list or via reaching out to you or just starting to do the work? Like what is that process like?
I think
maybe there's a PhD
those,
student somewhere who's listening to this.
I think all of those can work. You can just decide that you want to start using AO in one more place and some of those are not going to be very hard. And you can convert those to use a read stream to do to use AO for reads, and that can be done fairly easily, I think, in some cases. And you can reach out to me or to the entire list to ask for suggestions or to get review for those, or for the idea or the actual patch. You can also go to the PostgreSQL Hackers Discord. It's linked on the community website and ask for suggestions there. Another big area where I would definitely welcome help would be to review patches that are around AO. Like I, for example, posted patches for parts of the redesigns of the buffer manager. You would be more than welcome to review those. Yeah.
Okay. We'll definitely include a link to the Postgres Hackers Discord in the show notes for this episode, and as well as to the mailing list for anyone who's unfamiliar with that. I'm curious whether there's a list, like a punch list. You know how when a house is mostly built, but there's still this laundry list of some big, some small things that the builder still needs to finish? Is there a punch list for all of these pieces that still need to be built out to leverage AIO?
There's a wiki page, but it's not. I should probably go and update it. I did some work on updating it after AIO got merged, but it needs some more work. But that's probably a good place to look, but just with a caveat that it might not be perfectly up to date.
Okay. So it's a work in progress, if you will, and it'll change over time.
Definitely.
Depending on when somebody listens to this. Okay, so let's pivot to things that went right in the project, things that you feel good about, you and other people who you collaborated with.
I think the thing I feel best about is that we actually managed to get it done at all. When I started the project, I was not at all confident that this was a project that we could succeed in. I thought it was important to try to succeed in it, but yeah, I was not confident that it would actually work out. And that's definitely something I'm very happy and proud of. I think another thing that went well, and I think those are the parts, let me restart that. I think what went well was that we found sub-projects that could be merged independently and that helped independently, like the relation extension part that I mentioned earlier. Being able to upstream that first was pretty important, I think. Otherwise, having to also carry all those changes at the same time would have been very hard. And getting the read stream stuff into Postgres 17 and allowing various places to be converted to use the read streams was actually fairly crucial to make get Postgres to merge the AO in Postgres 18, because that meant that with just merging the AO subsystem and doing I think it was a few dozen lines of change in read stream, all of those places suddenly started to use AO, and that made it a lot more reviewable than if we, after merging the whole AO subsystem, had to also go into all these other places and change them to use the read stream interface, because that sometimes required non-trivial work in those places, because in some cases just to get rid of other architectural debt and similar things. I think some of the I think several people that worked on AO gained a lot of experience, and I think that was a pretty good success. And even though, as I'm sure that some people that might be listening would confirm, it was not always pain-free. And I would like that to have been a more pleasant experience, but I think it was still a lot of knowledge was gained across all the people involved. And I think that's great. Yeah, I don't immediately have other thoughts.
I mean, obviously, the fact that you got it done is something to feel good about, but I'm struck by what you said after that you were not at all confident this was a project we could succeed in. And I almost wonder, if that's your nature. Is it fair to say that you are inherently skeptical of something in the beginning, that you're picking up that idea and looking at it from different angles to figure out what could go wrong and obviously try to prevent those things from going wrong? Isn't that how you're wired, or am I misreading you?
I think that's part of it, but I don't think that is all of it. I've definitely tackled projects where I was 95% sure that I could succeed, just because I've been working on Postgres for a long time by now, and I know the community, and I can roughly predict whether something has a chance or is going to be controversial or not. But with the AO product, I did not have confidence in either my own skills from a technical point of view that it would be doable, and also on the community politics. I think that's perhaps one angle I forgot to mention earlier, which is that a change that is of this size, getting that into Postgres requires convincing a lot of people. And historically, our to-do list had a point that said we do not want to use direct AO. We do, and we just that's political things are a lot harder to predict than purely technical things. So I think, yeah, that's why I think I was more skeptical with this product than about other products.
Okay. So maybe let's just tease that out as something else that went right. I mean, you and the other people involved in the project were ultimately able to convince a lot of people. So it wasn't just a matter of doing the work, right, and getting it done correctly, but selling people and bringing the rest of the committer and contributor engineers along with you. That's something to feel good about too. Maybe that's what you meant before. Sure. It was implied. Okay. Are there Go.
It was implicit in what I said earlier, but another aspect I think that went right was to actually develop a prototype first, because without being able to just explore crazy things and then roll back and not be too worried about getting everything right, it would also have not been able to actually get to a design point where it was mergeable. And that was, I think, one more of those things where it was important to do, but I did it too much. But where the exact right spot is hard to tell. But I don't think without the plan to write a prototype that would not be mergeable, I don't think it could have gone anywhere. I think one more aspect that I think went okay, could have gone better, could have gone a lot worse, is corporate politics. Like I worked on AO, I think, while working at 2 different Postgres companies or 3 different Postgres companies. And you have to convince the companies to actually allow you to spend so much time on something that does not actually have very immediate benefit, because it was always clear that it would take a while to get merged, and that even then, like, it would take more years for it to get adopted. And I think that's definitely also an angle where I've had to learn a lot about how to do that and how to get buy-in into investing this much into a project with unclear outcomes. I think that went okay, and I'm proud
Well,
that
I
it
know when
did
you
not
gave your
go horribly.
when you gave the talk at Montreal, you actually gave a shout out to your boss, Afandar, for supporting you in your years working on this project. But I guess I've not been a fly on the wall in your one-on-ones with your boss, but it feels to me that there's a ton of support for what you and the team are working on, and the knowledge that, like, many of the decisions about what gets worked on in a future release or an upcoming release of Postgres, it's a very bottoms up process. Is that fair to say? And I feel like Afan is
Yes.
supportive of that.
Yes, I
So,
agree. It turns out there were several other I had other managers over time, and like I think they were all supportive, but in different ways. And I think
okay.
managing expectations of the timelines and stuff like that is pretty important. To just not, like,
Got it.
otherwise you deceive your own manager, which is not necessarily a good idea.
All right. So, other things that went right that you feel good about. I have one to throw out there. And you're gonna shoot me for bringing this up because your moment of fame is behind you. It happened in like whatever that was, March, April 2024, something like that. It was over a year ago. But were you actually, I think Thomas Monroe had sent you something and asked you to do some performance testing on it, and that's when you discovered the XC security backdoor and reported
That's
that
true.
security issue, and that kind of blew up the internet for a little while. But wasn't what Thomas Monroe sent to you to investigate, wasn't that AIO related?
That was the read stream interface.
Okay.
We were trying to figure out why it has some regression in some absurd workloads, and as part of that, I did all the tests where I then found that SSH was using too much CPU, and yeah, turns
Okay.
out that
So that's
it's
something
very
that
good
went right.
to learn about low-level benchmarking. It has unexpected benefits.
Yeah, I remember seeing an email from someone, I won't name names, but they were like, a database engineer wasn't going to be running low-level performance benchmarks like that. You've got to be kidding me. But they clearly have never met you, and or unaware of your commitment to investigating performance problems and getting to, I don't know, figuring them out. I mean, you can be very stubborn, can't you? Is that fair?
I refuse to answer on the grounds that it might incriminate me.
All right. I'm going to go look at the chat really quickly because there's a bunch of other Postgres developers who are on the live parallel chat that's happening while we're doing this recording live, just to see if there are any other highlights of things that went right that you're not thinking of right now. Because I'm fishing for anything else you want to call out. I mean, for a developer who's listening to this, is there anything else you did that you were like, huh, people making these kinds of large scale architectural changes should definitely do this, and we did it, and you feel good about it? Fishing.
I mean, I think one of the things that turned out to be very crucial for being able to merge AO was that we got a lot of review by Noah Mish, and that was not something that actually I had planned upon and that planned for. And I think that went very well, and I'm very, very thankful for Noah that he invested so much time in it. And I think in hindsight, I would have probably tried to do a bit more backroom dealing for like trading of reviews with other people to line them up ahead of time so that I could be more confident that it would be review. Because like I think it's from a community politics perspective and from I know diversity of thought, as maybe sounds not quite right, but like if you work closely on one product together, like the team at Microsoft on AO, then you might not see problems that somebody that comes more freshly from it at the problem from the outside will see. And that was definitely the case with Noah. He found a lot of problems that I just did not think about. And I'm glad that that happened. But in hindsight, I should have invested more. Like that was luck. That was not skill that happened. And I think luck is a skill, but I would invest more in trying to line that up ahead of time next time.
So to try to put a fine point on what you just said, it wasn't luck that Noah found the problems, because that's something that he's probably good at. It was luck that you enlisted Noah to help do the reviews and find the problems. Is that correct?
I did not enlist Noah. He volunteered. That's the luck.
Oh, he volunteered.
Did it.
Even better.
Yes.
So for those of you who don't know Noah Mish, he's a Postgres committer and contributor. He works at Google. I think the first place I ever met Noah was at PGConf Dev in Vancouver last year. And he was there again this year too. So that's the annual conference where a lot of the Postgres contributors and engineers come together. And some users, but I would say mostly contributors. So, okay, so you've given shout outs to Thomas Monroe, Bilal, Yavuz, Melanie Plagueman, and now Noah Mish. Is there anyone else that you need to be sure to give a shout out to? Or are there too many people to possibly list? This is like the Academy Awards now, where you're trying to fit everybody in.
Oh, sorry.
Who?
Say again? Thomas Munro, I think, did a fair bit of work too. Like both on the actual AO subsystem and then upstreaming the ReadStream interface in a very different form than what I had prototyped. And then I think I had a lot of discussions with various people over the years about different aspects of it. But I think the people that were just mentioned are the most important ones.
One of the things that Melanie just chimed in on the chat and said is that getting someone experienced to review these architecturally significant patches is hard because it's just so much work. It takes forever to do, she said. And that is probably what makes Noah's contribution so good, that he not only do it, he volunteered for it, is what you're saying. Okay, yes. So you've given a shout out to Thomas, to Bilal, to Melanie, to Noah. Is there anybody else that you want to shout out to?
Or I would probably have to look in the commit message. And there were lots of other like smaller projects that were done. I think David Rowley did some prerequisite work. I had a lot of discussions with Robert Haas about architectural aspects. I had lots of discussions about parts of it, and he did also do some review with Heikki Linnakangas. But I'm sure that there's many more that I am just not thinking of right now.
Well, and that's one of the things that's nice. In the commit messages, the team does a really good job, and I'd say a better job this year than in the past, of including like who reviewed this commit, who were the authors, who tested it, who was it reported by. Like, I mean, I think in a lot of open source projects, giving credit where credit is due is an important part of the culture. And I think that's certainly true in Postgres as well. So yeah, it's fair to say that there's a lot of other names that are listed in the plethora of commits that are associated with this project. Okay. So, are there any other lessons you want to highlight to someone who's listening who maybe is about to embark on their own architectural project and is trying to make sure they only make original mistakes?
I think one other aspect that I only somewhat mentioned is to take care of yourself if you do something that takes this long. I found that development progress definitely was associated with how well I was doing in my personal life and exercise and all that kind of stuff. And that I feel that more strongly with products that take this long because like I can look back and remember I was working on this part when I was like sick or something like that. And I think that is particularly for long projects something to remember, that it's important to take care of yourself and not just invest into the product and do more and more hacking.
Um, there was a woman that I used to spend a lot of time with at swim meets. Both of my children were competitive swimmers growing up, and when they're at swim meets, oftentimes you're literally standing by a pool for the entire day, like for hours and hours. Like you're there for the whole day, and they swim for 3 minutes or something like that. Um, but she had just taken a job. It was a really big job as an executive. And what she realized in taking on all that additional responsibility is exactly what you said. Like she had to take care of her body in order to be successful in her job. So she had to change her diet. She had to find a way to like exercise and have an exercise routine that she could do even when she was traveling and in hotel rooms. Um, so I think you're right. You got to take care of yourself, or your brain isn't going to be able to do everything you need it to do. So that is worth shining a light on. I'm glad you brought it up. Anything else you would tell past Andres if you could go back and
I mean,
whisper in your
all the
own ear?
mistakes I mentioned, I would tell like all the if I knew ahead of time which architectural decisions would be wrong and which prerequisites could be tackled independently earlier, then I would probably do that. But that feels like it's not really the answer to the question. Yeah, I
Oh,
don't
it's the
think I
answer to the
otherwise
question.
have very smart to say, unfortunately.
Okay. All right. Well, before we wrap, um, I I guess I'm curious. You're here on a podcast. This is the second time you've been on the Talking Postgres podcast. Thank you for that. I really appreciate it. I didn't know if you would say yes, but I thought it was important for you to share your learnings from this project so that it will benefit other people. But I'm curious, now that you've been a guest on this podcast twice. You've also been a guest on Oxide and Friends and another security related podcast, maybe even more that I don't know about. But I'm curious whether you listen to podcasts.
I do listen to podcasts, but mostly non-technical ones. I think most of the time when I'm listening to podcasts, I'm trying to like let my brain do something else rather than focus on technical things because I already spent way too much time thinking about Postgres and stuff like that. I occasionally do listen to technical podcasts, but it's mostly when somebody mentions that something is particularly good or when it's like very square in my interests. But most, yeah,
Well,
it's not. I
I
don't listen to too
think,
many technical ones.
okay. Well, I won't put you on the spot and ask you what they are. But I will say thank you for the work that you do on Postgres. For those of you who don't know Andres's origin story, like I said, you should go back and listen to, I think it was episode 8 of Talking Postgres, where he and Heikki dove into how they got started. But you got started in kind of an unusual path, and I don't know, it's almost happenstance that you landed in Postgres. And I think it's fair to say that I and a ton of other people are really glad that you did. So I feel very lucky to work with you. And I guess that's a little bit of a fangirl type of thing to say, but I do. So I'm saying it.
Thank you.
Yeah, and thank you so much for joining the show. I don't have any other topics or questions for us today. So unless you
Cool.
do, we will give it a
Don't
wrap.
forget
I
it
want to
right
say
now.
thank you. Okay. I want to say thank you to Anders Freud for joining us. And if you're listening and you liked today's episode, and I hope you did, and you want to hear more of these Talking Postgres episodes, you should subscribe on Apple or Spotify or YouTube or wherever you get your podcasts. And please tell your friends. If you tell your friends or leave a review, that helps more people discover the show, which is word of mouth is the best way to discover a new podcast. You can always get to past episodes and get the links to subscribe at talkingpostgres.com. And transcripts are included on the episode pages on talkingpostgres.com too. And a big thank you to everybody who joined the live recording and participated in the live text chat on Discord.